Good afternoon. Thank you for coming. I am Ken Exner, Director of Developer Tools in AWS, and this is Managing Deployment Complexity. So a couple years ago, we were talking to customers of AWS, businesses and enterprises who were looking to move to AWS, and we started noticing a familiar pattern in the conversations that we were having. We'd be talking to companies about moving their workloads to EC2 or S3, and they would interrupt us and say, great, like we're botting on the cloud, all great, but we're kind of wanting to understand how you guys do this inside of Amazon. These companies were wanting to understand what tools and processes we used in Amazon that allowed us to be agile. They had heard that we were famously a DevOps-oriented culture, that we practice agile processes, and we were, of course, the guys behind the cloud, and they wanted to understand, what do you guys do? What tools and processes do you use? So in this talk, I'm going to answer some of those questions. I'm going to look back at the history of Amazon and talk a little bit about the tools that we developed inside of Amazon and the processes that we use inside of Amazon to deliver software. In addition to talking about the history and the tools that we developed along the way, I'm going to talk about how some of those tools are now available to you guys, our customers, as AWS products. Three products I'm going to talk about are AWS CodeDeploy, the new deployment system that we launched last November, AWS Code Pipeline, and AWS Code Commit. At the end, I'll finish with a summary and some Q&A if there's time. But first, let's talk about the transformation that Amazon went to get to DevOps. We didn't always start off as a DevOps-oriented culture, a DevOps-oriented company, and it took us a while to get there. And if you go back, let's say 15 years, actually let's say 14 years to 2001, Amazon.com started off as a monolithic architecture. This meant that it was one code base and it was deployed as a monolith. There weren't a bunch of different services. It was basically just one big monolithic architecture. It was an interior architecture, but it was one monolith. And as typically happens when you have this style of architecture, things started getting slow. We started bottlenecking in terms of our deployments. Every time we want to push out a change, we would have to regression test everything that we had done. We'd add more people to the project, and we weren't scaling. We'd add more people, and we wouldn't get a commensurate amount of productivity out of the people that we were adding to a project. So we realized that something had to change. We had to move away from this monolithic architecture. And what happened is we made two changes that had a very fundamental and profound change on Amazon. One was an architectural change, and the other was a cultural or organizational change. Talk about each of these. The architectural change that we made was moving to a service-oriented architecture. So we took the monolith, literally exploded it, turned it into a bunch of services, and put a service in front of everything. Everything got an interface, and everything communicated via these interfaces. If you look at this picture, it kind of looks like the Death Star, I suppose. It's literally a depiction of what Amazon.com, the retail site, looked like after we had made this transformation. And what you see here is a bunch of little boxes, purple, bluish boxes, pink boxes. Each of those represents one of these services. And these services communicated with the other services via these interfaces. So we had successfully taken the monolith, exploded it into these little services, and everything got an interface, and we communicated via these interfaces. One of the other tenets that we had is that each of these services had to be small, had to be focused, had to be simple. And this is because we were moving from this monolithic architecture. We wanted to make sure that we went the other way. We went to small, simple, focused. And we called this style of architecture primitives. We were developing primitives, and we had a primitive service for everything. We had a primitive service for tax calculation, so how you calculate tax on the site. We had a primitive for how to display the buy button. Everything got an interface, everything became a primitive, and we were essentially going down the path of microservices. We didn't know at the time, but we were creating the service-oriented architecture composed of these small primitives. The second change that we made was an organizational or cultural one, and that is moving towards agile processes, and as part of that, decentralizing the organization. So we used to be more centralized, the one big dev team, one big ops team, and we broke that apart and decentralized everything into small autonomous teams. We actually had a term for this. We called it two pizza teams. This was kind of a clever way of describing the fact that we wanted these teams to be small. A team could be no bigger than could be fed with two pizzas. I always thought this meant two people teams because who knows. It actually meant we wanted teams to be 8 to 10 people. I don't know how 8 to 10 people eat 2 pizzas, but there you go. They were lean, hungry teams, and they were self-contained. They were completely autonomous. And this was important because we were trying to preserve our startup heritage. We wanted these teams to act like little startups. So essentially, these teams became completely autonomous and had full ownership of what they owned, which meant they owned development, they owned testing, they owned operations, they owned product management, everything end to end. So these small little teams emerged that owned these primitives that had end-to-end ownership. And we didn't know it at the time, but essentially we were starting to move towards DevOps. The idea that you don't have teams owning development, teams owning operations, you had teams that own everything, end to end. You had teams that own development and operations. So Amazon essentially became a company that had thousands of little startups underneath one umbrella. When we made these 2 changes, the move to a service-oriented architecture and the move to this agile process with these decentralized 2 pizza teams, we realized we needed new tools. The tools and processes for how we developed and released software didn't work anymore. We used to literally have a centralized deployment team, one team that did nothing but deployments. They deployed the retail site. Well, in a world where you have literally thousands of teams, all with their own environments, all with their own services, this doesn't work. So we built up a tools team inside of Amazon that was responsible for building tools for this new decentralized world, where tools needed to be self-service, tools needed to support this DevOps culture. Tools also needed to be technology agnostic. This is an important one because Amazon isn't just a Ruby shop or a Java shop. We have every technology in use under the sun underneath Amazon. So it had to be technology agnostic. So all the tools had to be technology agnostic. And the other thing was pretty important to us is that we wanted to make sure that as teams began using these self-service tools, that they would benefit from lessons learned from previous teams. So we wanted the tools to provide best practices and guardrails. So anything that we learned along the way about how to do deployments, how to release software, we wanted to codify those best practices into the tools and provide guardrails. So a couple tools emerged in this time frame. One was Apollo. Apollo was a name clearly borrowed from NASA, and it was, or is, our deployment service in Amazon. It is how we deploy everything at Amazon, from the retail site to our web services. Everything is managed through Apollo, and this is how we get bits on a box. It's how we do software change. This was first used over a dozen years ago, and we've been improving it ever since. It was pretty rudimentary when it first came out, but over the last dozen years, we've gotten smarter and smarter about how we do deployments, and Apollo has gotten smarter and smarter. The workflow engine behind Apollo has picked up a lot of lessons learned in those 12 years. One of those lessons is that we wanted to make sure that we could do deployments without impacting our customers. So we wanted to have 0 downtime deployments. So if we push out a change, you go to the retail site, you don't see that you're getting 500s every time we do a deployment, and that's because we figured out how to do rolling deployments that don't impact customers. We also figured out how to isolate errors. So if we have any kind of problem during a deployment, that we don't propagate that to the rest of the fleet. We quickly isolate it and roll it back. So Apollo became very useful in terms of mitigating any impact we had to customers from bad deployments or script failures or anything like that. It also provided a central control point for knowing what version of software was running anywhere at Amazon. So we could see what version of software and we could see the history of all the deployable artifacts that we had and what they were running at any one time. Another tool that we developed in this time frame was pipelines. And this is our continuous delivery service used pervasively across Amazon. And the story here goes back to 2008. And there were a couple guys in the tools team that did a study of how long it was taking us on average at Amazon to go from code check-in to having that code running in production. So basically, from code check-in to build to test to deploying across different environments to finally having that running in production. And they measured that and took the average across all of Amazon. And they presented that to the executives, and it was embarrassingly long. It was literally weeks of time spent going from check-in to production. And it wasn't that any one of those steps was taking long. It wasn't that the builds were taking long, although developers sometimes complain about that. It wasn't that tests were taking weeks. It was all the manual steps in between. It was all me sending a notification to another person, that person batching up a bunch of changes, weekend coming, nothing happens the weekend. A bunch of these human processes that were slowing us down. And you have to understand, for a company like Amazon, we pride ourselves on having efficiency. Everything we do is efficient. Everything we do has to be efficient. We're the guys with robots in our fulfillment centers. So when we saw this production line that was broken and manual, we said we need to fix this. We need to completely automate this. We need to make sure that all those human, manual, air-filled tasks that are going on in that production line get handled by automation. So Pipelines was developed as a release automation tool that went from code check-in to having that in production and managed the entire process. Today it's used by well north of 90% of the teams, and it's how we automate everything inside of Amazon, from the retail site to S3 to all our services. We model everything in pipelines. All right, so what happens when you have thousands of teams at Amazon, all moving towards these microservices or primitive style architecture, having multiple environments, so different production environments, different pre-production environments, practicing continuous delivery? You get a ridiculous number of deployments. Last year at Amazon, we did over 50 million deployments just inside of Amazon. These are just the teams at Amazon. 50 million deployments through Apollo. Pretty astounding number. That's a deployment and a half every second. So, going back to our customers, when our customers asked us, what do we do inside of Amazon? How do we deploy and how do we release software? Do we have anything that could help them? We said, sure, of course we do. So in this talk, in the remainder of this talk, I'm going to talk to you about the new code services, CodeDeploy, CodePipeline, and CodeCommit. And I'm going to talk to you about how you can use these services to develop your own DevOps pipeline that will allow you to automate your entire DevOps pipeline from source code check-in to build to various testing stages to production, and make that completely automated the same way Amazon does. And deploy to your different environments the same way Amazon does. This will allow you to be more efficient, to be more responsive to customers, to be more agile. All right, let's start with AWS CodeDeploy. So first ask, why do we need a deployment service? Well, one is you're going to want to automate your deployments. Automated deployments are pretty much a fundamental ingredient to any effective DevOps pipeline. You're going to be doing lots of deployments. Because you're doing smaller changes, you're not batching up changes, you're going to be pushing a lot more changes. You're going to have multiple environments possibly, different testing environments, different production environments. And you're going to start automating this, so you're going to need to make sure that you're not having any friction in terms of deployments. You're going to want that to be as efficient as possible. Another reason is you want to manage complexity. Now, if you're a single developer and you're deploying to a single box, it's pretty straightforward. You just SSH into the box, you run your scripts, and you're done. But if you add more developers to a project, and they're all trying to hit the same box, trying to do multiple deployments to the same box, it gets more complicated. If you have more than one box you're deploying to, maybe a fleet of a dozen instances or hundreds of instances, you're certainly not going to want to SSH into those boxes and run that manually. So you're going to want to manage complexity as you get bigger in terms of team size, as you get bigger in terms of the number of target hosts that you're deploying to. And you're going to want to avoid downtime. You're going to want to make sure that your customers aren't seeing your app spitting 500s every time you're doing a deployment. You're going to want to make sure that customers don't get impacted every time you do a deployment. And then if you have any problems during a deployment, any kind of failures, that you can isolate that and capture and make sure that that doesn't propagate. So that is why we introduced AWS CodeDeploy. This is the deployment service that is based on Apollo, the internal deployment tool that we use at Amazon. It is available today. It's available generally. It was launched last November. And it allows you to automate your deployments just like Amazon does. All you need to do to use CodeDeploy is you teach it how to deploy to one instance, and then it'll take care of doing that across any number of instances. So you can deploy the same way to hundreds or thousands of instances the same way as you would one. You can also deploy without downtime. You'll take advantage of a lot of the techniques that Amazon learned along the last dozen years about how to do rolling deployments and how to mitigate any impact to customers during a deployment. This will also give you the ability to see what environments are running what software at any point in time. It will give you centralized control and monitoring of of what software is running on your different environments. And best of all, there's no additional charge to use CodeDeploy. So it's available today with no additional charge if you're deploying to EC2. One caveat to that is we did announce a new feature last week that we're very proud of. And this is the ability to deploy to on-premise instances. We do charge for that. There is a 2-cent per instance update fee for deploying to instances on-prem. So it's free to use, no additional charge if you're deploying to EC2. If you're deploying outside of EC2, to basically anywhere, your laptop or instances in your own data center, there's a 2 cents per update charge. But this is pretty cool because it means that you can use one deployment system to manage everything. This will handle hybrid scenarios where you want to deploy to an environment that's mixed between on-prem and cloud-based environments. It will allow you to have testing environments that are local and production environments that are in the cloud and still use the same deployment tool. So pretty powerful things. To use the on-prem feature, you just install the agent on your device, and basically any device with an internet connection that can call to us can receive a deployment. So you can deploy to your laptop, you can deploy anywhere using the same deployment service that Amazon uses. All right, so let's take a look at how to use CodeDeploy. There's 3 simple steps to using it. The first step is you're going to need to package up your application, and when you package up your application, you're going to include with that what we call an app spec file. And an app spec file, this is an example here, it's just a bit of configuration. It's YAML code, for those who don't recognize that. This is a bit of configuration, and there's two parts to this. There's a files section, and this teaches CodeDeploy where to copy files from and to. So where do you want files copied? And there's a hooks section. And there are 7 lifecycle events that happen during every deployment for CodeDeploy. And CodeDeploy will step through those 7 lifecycle events. And for any of those lifecycle events, you can attach your own scripts. There are hooks that you can attach your own scripts, and those scripts can be anything. And this is a pretty powerful concept. That means your scripts can be PowerShell. Your scripts can be Bash scripts. They can be chef recipes, as this example shows here. They can be Puppet. They can be Salt Stack Ansible, whatever you want. This goes back to the tenet that we had that we have to be technology agnostic inside of Amazon. We have to be configuration management agnostic, and the tools we provide need to work with whatever customers want. So this is a feature that allows you to bring your own scripts, whatever they are, as part of a deployment. All right, so once you've set up your app spec file, you're then going to create your target environments. And in CodeDeploy, we call these target environments a deployment group. And those are the instances that are going to be receiving a deployment. So in this example, there's a deployment group for staging, and there's a deployment group for production. You can define a deployment group one of a couple ways. You can define it with tags. So if you're using EC2 tags, you can tag all your instances a certain way. Maybe environment equals production, environment equals staging. And that will tell CodeDeploy that that is your deployment group that you want to receive a deployment. You can also define a deployment group with autoscaling. So if you're using EC2 autoscaling, you can point CodeDeploy directly at an autoscaling group and say, that's my deployment group. Not only is it going to be simple and integrated, but it's also going to integrate with features of autoscaling. So when autoscaling wants to bring up an instance in response to some kind of metric, it's going to want to autoscale up. It's going to talk to CodeDeploy. It's going to make sure that you're running the right version of software on that instance before it puts it into service. So pretty cool feature that makes sure that the instances that autoscaling is bringing into production match the rest of your hosts, match the rest of your instances in that autoscaling group. And it also works with on-prem. So there's an on-prem tag that you can use if you're using this with on-prem. All right, so once you've created your app spec file, you've created your deployment group, the next step is you're going to deploy. And this is pretty straightforward. It's a simple button click in the console. You can use it by command line tool. You can use it by SDK. Because this is also completely API-based, and we have a number of partners, you can use third-party tools to kick off a deployment. I'll show you a number of these in a second, but a number of CI/CD tools have built-in integrations that allow you to automatically kick off deployments to CodeDeploy from Jenkins, from Bamboo, if you're using Atlassian, from Solano Labs, Circle CI, CodeShip, Travis, if you're using Travis. A number of different vendors have provided integrations with CodeDeploy that will automatically kick off a deployment after you use those tools. Another partner that I'll actually demo for you guys is GitHub. GitHub has provided an integration that allows you to automatically kick off a deployment after a commit in GitHub. And I'll show you that in a second. One feature talk about before we get to the demo is what a rolling deployment is. CodeDeploy allows you to tell us how quickly you want to push out a deployment. And you're going to want to balance speed with availability. And this can be anything from one at a time to all at once. And the reason that matters is you want to make sure that you have some hosts serving up traffic at any point in time. So you don't want to do all at once necessarily because you want to make sure that you have some instances that are serving traffic. Give you an example of this. Say, for example, you have 3 instances running version 1 of your software sitting behind a load balancer. And you've told CodeDeploy to deploy 1/3 at a time. In this case, 1/3 at a time would be 1 instance at a time. What CodeDeploy is going to do is it's going to take 1 instance out of the load balancer. It's going to update it to version 2, and then put it back in. And then it's going to go to the next instance, update it to version 2, put it back in. And onto the third, and the same thing, update it to version 2, and put it back in. It's essentially done a rolling deployment that allows you to go to version 2 while still serving traffic with the other 2 instances. Let's say you have a problem during a deployment. And maybe one of your scripts fails or one of your validation step fails. CodeDeploy will automatically stop the deployment. It'll abort the deployment, and it'll allow you to roll back to version 2. So it'll make sure that you've had an error. It doesn't let you propagate that error to the rest of your instances. It stops. It allows you to roll back and restore to version 2. All right, enough talking. Let's do a demo. You guys know the magic 8-ball? You shake the magic 8-ball and it gives you a witty response. Someone on my team wrote a magic 8-ball app. Can you bring up the demo? Flip to. Nope, that's not it. Roll back, yeah. Magic 8-ball, is this demo going to work? We'll give it one more second. Future is cloudy, yeah. No? Five seconds, and we'll move on. Yeah. It's a really cool demo. I'll describe it. So with GitHub, you can, they've provided a post-commit hook that allows you to automatically deploy to CodeDeploy after check-in. So after a commit or after a pull request, any kind of commit to GitHub, you can automatically trigger deployment. It's a pretty smooth, seamless integration that allows you to go from the GitHub experience, from doing pull requests or whatever you're using in GitHub, to automatically kicking off a deployment. Pretty cool feature. Nope, can we go back? So GitHub is one partner. We also have a number of other partners. I mentioned some of these earlier. GitHub works if you're going from source code to a deployment, but oftentimes you need to have a build step in between or testing steps. And if you need those, you can use Travis, you can use CodeShip, you can use Circle CI, Solano, Atlassian, their Bamboo product. All these companies have provided integrations with CodeDeploy that allow you to automatically kick off a deployment. We've also partnered with a number of the configuration management companies like Chef and Puppet and Ansible and SaltStack so that you can use those tools with CodeDeploy. And if you go to our GitHub repository, AWS Labs, you can find a number of templates for how to use those configuration management tools together with CodeDeploy. You'll see samples for Chef, Puppet, and a number of products there. And it's because you can use whatever scripts you want as part of CodeDeploy. All right, let's talk about AWS Code Pipeline. Oops. And let's first ask, why do we need release automation? Well, once you automate your deployments, you're going to want to automate your entire release process. You're going to learn, like Amazon did, that you're going to have a lot of wasted cycles in terms of waiting for people to push out changes to the next environment. You're going to want to automate that entire end-to-end process. This is going to allow you to release more quickly, but it's also going to have a higher quality release for a few reasons. One is you're not going to have as many human errors, human mistakes as part of that, and you're going to have a more consistent release process. Now, oftentimes we tend to have people that have all these things that are in their heads about how to do a deployment, and they've captured the best practice in their heads. You want to make sure that anything that a person is going to be doing, anything a human is going to be checking, that you put that into a script. You put that into automation. That way you're not dependent on that person remembering to do that one check or that one regression. You're not dependent on that person teaching every new person that comes onto the team. So anything that you can do as part of a release process, put it into automation. You'll have a better, higher quality release process. So we've been working on AWS Code Pipeline. This is based on the pipelines product I talked about before. It's pipelines that we use inside of Amazon. Code Pipeline is the external version of that. And it allows you to automate your release process just like Amazon does. This will allow you to go from code check-in to having your code in production and everything in between automated. There's a couple key tenets that we had in developing this product. One is it had to be extremely flexible, and the other is that it had to be extensible. In terms of flexibility, we wanted to be able to model anything. So inside of Amazon, we model the retail site this way. We model all our services this way. This example here on the screen shows you going from source to build, and doing some unit tests, then deploying to a beta stage, a pre-production stage called beta, then doing some UI tests, then deploying to another pre-production stage called Gamma, doing some load tests, and then deploying to 3 different regions of production. Anything like that, more complicated, less complicated, can be modeled in Code Pipeline. It's how we model everything inside of Amazon. The other critical tenet that we had in developing this is that it had to be extensible. We heard from our customers that they wanted to be able to continue to use whatever tools they use today with Code Pipeline. So if they use Mercurial as their source control system or GitHub as their source control system, if they use Jenkins as their build system, they wanted to continue to be able to use that. And they wanted to be able to mix and match whatever tools they wanted as part of this. So this was pretty fundamental to the design of Code Pipeline. So we built the entire thing on a plug-in architecture that allows you to plug into any of these stages. And we built our own integrations on top of those plugins. So we built a CodeDeploy integration into Code Pipeline on this plugin architecture. We're building a code commit integration into this with this plugin architecture. A number of our partners, some of the partners I showed you previously, are also building plugins to into this architecture so that on day one you'll be able to use this together with a number of third-party tools. Third-party tools for build, third-party tools for test, also third-party source control systems, even third-party deploy systems. And the other thing is that customers can also provide their own plugins. So if you're using this and you want to have a plugin for your account that allows you to talk to a source control system locally or talk to some testing tool that you have inside your house, inside your business, you can create a plugin that allows Code Pipeline to call out to you to do testing or whatever you're wanting to do. So 3 levels of customization there. We are building plugins to this, third parties are building plugins, and customers can also build plugins to this that would be available for their accounts. I'm going to do a demo. Is it going to work? This would be the first time we would show Code Pipeline in public. If the gods will have it. Ah, awesome. All right. Well, this was the Magic 8-Ball app that I was going to show you. It's very cool, but you're not going to see it. If you want to stick around afterwards, I can show you the Magic 8-Ball app if you guys are interested and show you how to do the integration with GitHub. But I'm going to use this time to demo Code Pipeline. You can see here Each of these boxes represents what we call a stage. And there's two main concepts in code pipeline. There's stages and there's actions. So there's a source stage here that contains an action to pull from GitHub. There's a build stage here that is running a build on Jenkins, and this is in progress right now. There is a beta stage followed by a production stage or a prod stage. And in this beta stage, this demonstrates a couple things. It demonstrates how actions can be serial or they can be sequential, or parallel or sequential. First, there is a deployment using CodeDeploy to a beta fleet, followed sequentially by two parallel actions. One is doing a load test with SOSTA. Another is doing a UI test with Sauce Labs. After these complete, after these parallel actions complete, it's then going to move on to prod. And what I've done here is I've inserted what's called a gate. And a gate can be, there's a number of different types of gates, but the one that's demonstrated here is a manual gate. This is basically, it's not going to proceed until someone who I've indicated as the approver approves this. But a gate can be a number of different things. We'll support gates that are time-based so that you can only deploy in certain times. Gates that are based on metrics. Maybe it's going to look for some metrics, make sure things are clear before it proceeds. So a lot of powerful concepts with gates. You can also sort of manually stop the pipeline at any point by clicking on the blocker there. So that gives you an idea that there are these stages comprised of these actions, and these actions can be sequential or parallel. Actually, I'm going to edit this and just show you. This is the edit or design view of Code Pipeline. And I'm going to edit this action here, which pulls from GitHub. And you can see here that there's, I can pick different source control systems. Maybe I want to just pull from S3 or code commit. Maybe I have my own custom Perforce source control system that I use in-house. If I did, I could create a custom action to pull from that repository in my own business, and that would be a custom action. Or I can change this to be a deployment action, and maybe I want to deploy to OpsWorks or Beanstalk or use third-party deployment tools. Again, the idea is that we are building plugins to this. Third parties can build plugins. Our customers can build plugins to this in the form of these custom actions. And then model everything end-to-end the same way that Amazon does. All right, let's move back to the slides. Okay. All right, so I've talked to you about how to automate your deployments. I've talked to you about how to automate your release process with Code Pipeline. Now let's look at the source control system at the very front of that. And I'm talking to you about code commit. This is an area where we talked to our customers and they said, if we're going to be moving all these tools and all these environments to the cloud, if we're going to be moving our build environments and our testing environments and our production environments to the cloud, why not also move our source control systems there? Why not also have our source code next to the build and test systems that we're going to be using? And they wanted this for performance reasons, lower latency between deploying and between doing your builds and your source control system, but also they wanted something that was fully managed. They didn't want to have to continue to manage their own Git repositories locally or whatever source control system they wanted. They wanted something that they could just turn on in the cloud and that would be fully managed. The other thing they wanted was something that would be highly available, especially as you start getting into DevOps where you're doing lots of releases and your automation tools are pulling on your source control systems. You're going to want it to be highly available. The most important thing we heard was that it had to be not just as secure, but more secure than what customers could do themselves. They wanted something that was more secure than what they would do. And then the last thing we heard is that customers wanted to be able to store anything. They didn't want to have the traditional limitations of, objects can only be a certain size, repositories can only be a certain size, they can only have a certain number of repositories. They wanted the promise of the cloud brought to source control systems. They wanted to be able to store anything, store their binaries together with their source code. So we've been working on code commit. And code commit is essentially Git on top of S3. It allows you to host private Git repositories in the cloud. Git on top of S3. That means you get the best of both worlds. You get the familiar Git interface, and you get all the characteristics of the cloud. If you're using Git today, all your existing Git-based tooling will work. Your existing Git-based clients will work. It supports all the operations of Git, so it's a full fidelity implementation of the Git protocol. But it's also based on cloud-based services, which means you get the availability characteristics of the cloud. You get the durability characteristics. Everything is stored across multiple availability zones for redundancy, durability. You also get the scaling characteristics of the cloud. There's no limit on the number of repositories, no limit on how big a repository can be, no limit on how big an object in your repository can be. It's pretty cool stuff. And it is very secure in that it is integrated with IAM as well as the key management service. The integration with IAM allows you to provide fine-grained permissions on your repositories and use the other characteristics of IAM so you can integrate with your AD directories or use SAML integration if you're using that as part of IAM. And the integration with the key management service, AWS KMS, this is the service we launched last year that allows you to use your own keys to encrypt data in S3 and RDS and other services. You can use your own keys with KMS to encrypt data in code commit. That means all data in code commit is encrypted in transit and at rest. And it is the exact same Git experience. So all the operations that you would normally use with Git, git clone, git commit, git push, they all work the same way. The only thing that's different is you're pointing at an endpoint in AWS. Otherwise, it is the exact same experience. And all the other Git-based tools, like Garrett and other Git tools, will work on top of this. All right, to summarize, AWS Code Commit is coming soon. This is our private Git repository. It is essentially Git on top of S3. It is going to be coming soon, but you can sign up for the private beta. We are letting customers into the private beta right now, so if you are interested and want to try it, I encourage you to go to the Code Commit site and sign up for the private beta and get into that. Code Pipeline, also coming soon, but we are letting customers into the private beta, so same story. Go to the Code Pipeline website, sign up for the private beta, and we'll let you in waves. And AWS CodeDeploy, the deployment service based on Apollo, is available generally now. It was launched last November. There's no additional charge to use CodeDeploy unless you're using it with on-prem instances. 2 cents per instance update with on-prem, no additional charge with EC2. I encourage you to try that out. I will stick around if anyone wants to see the demo or wants to talk or ask questions. Thank you for coming.